உள்ளார ஃப்ளோரிங் பண்ணுறாங்கல்ல, அது வண்டியில் பைக் வச்சுருப்பாங்க. எதுவும் பிரச்சனை அதெல்லாம் எப்படி மூக்கிட்டே இது பண்ண இப்படி இருந்து இப்படி ஆகி படக்கு படக்கு படக்குன்னு ஆயிடுது. ஃப்ளோரிங்கே
Good evening. So yesterday I was talking about carbohydrates, then glycosaminoglycans. Today I told you I will be talking about lipids. It's one of the most important biomolecules of our body. Very simple thing, it is not soluble in polar solvents. Polar solvents, it is soluble only in fat solvents like ether, diether, ether, chloroform, acetone. The normal classification is neutral lipids, conjugated lipids, and derived lipids. Three of them. When I talk of neutral lipids, we have fatty acids and triglycerides, otherwise called as triacylglycerol. Conjugated lipids, we have glycolipids, phospholipids, sphingolipids, and derived lipids, steroids, terpenes, tocols. You can put them in derived lipids. Many textbook may put something else, but this can also be considered as derived lipids. Before we go into fatty acids, the neutral lipids, triacylglycerol. That is the storage form of fatty acid, and they are stored in adipose tissue. Tri means 3 fatty acyl groups attached to one molecule of glycerol. That is why it is called triacylglycerol. Glycerol is what? CH2OH, CH2OH, and CH2OH. That is, CH2O is combined with the fatty acyl-CoA, CH2O combined with fatty acyl-CoA, then on third molecule again fatty acyl-CoA. So if you remove one fatty acyl-CoA, it is a diglyceride. If you one more fatty acyl-CoA is removed, it is monoglyceride. Then if you remove all the 3 fatty acids, it becomes glycerol. Fatty acids can be 2 carbon atoms, 3 carbon, that is acetyl, propane, butyl. So we can say medium chain fatty acids, long chain fatty acids, and very long chain fatty acids. In metabolic pathway, we are most concerned with the long chain fatty acids. Long chain fatty acids in the sense they have carbon atoms, 16 carbons, we call it as palmitic acid. 18 carbon atoms, we call it as stearic acid. In the palmitic acid, if you put a double bond between 9 and 10, we call it as palmito-oleic acid. If the stearic acid, 18 carbon, if you have the double bond at the night position, we call it as oleic acid. See, our body cannot introduce double bonds beyond carbon atom number 9. So those compounds that cannot be synthesized by the body, which has to be supplemented in the diet, we call it as essential, whether it is fatty acids, whether it is vitamins. Any compound that is not synthesized body, it becomes essential. So essential fatty acids. They are supposed to be three. They are linoleic acid, and arachidonic acid. Linoleic acid has a double bond with two double bonds, 9th and 12th. Linoleic acid has three double bonds, 9, 12, and 15. Arachidonic acid has 5, 8, 11, and 14, four double bonds. So naturally, these things are supposed to be supplied in the diet, and that is why they are called as essential fatty acids. Because they are having more than one double bond, they can also be called as polyunsaturated fatty acids. We call it as PUFA. So when you imagine a fatty acid, no need to look at the structure, just imagine. Always remember the first carbon atom will be CH3. Then it is followed by CH3, CH2, 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 CH2. Depending upon how many carbon atoms are there, we can say CH3, CH2, power of N, period, carboxyl group. So anything that is, for example, either you can call it from the carboxyl group, from the methyl group to carboxyl group. So we'll come to this important polyunsaturated fatty acids in detail when we are talking about prostaglandins. Why? Because polyunsaturated fatty acids are very important in our system. Why? Because they supply, they are the essential things for the synthesis of prostaglandins, one of the most important biomolecules in our system. We will see these prostanoids at the last part of the lecture today or tomorrow. At that time, I will talk in detail about this because this requires a detailed discussion. Then we have conjugated lipids. So please remember today what I have told you is palmitic acid, oleic acid, palmitoleic acid, stearic acid, and oleic acid. Then I talked about polyunsaturated fatty acids, linoleic acid, linolenic acid, and arachidonic acid, which have double bonds, 9 and 12, 9 and 12 and 15, 5, 8, 11, and 14. That is arachidonic acid. So if you supply one fatty acids, either linoleic acid or linolenic acid, arachidonic acid can be synthesized. So if you are very serious about the discussion, we can say linolenic and linolenic acid are the most important essential fatty acids that needs to be supplied in the diet. Conjugated lipids, we can say phospholipids, glycerophospholipids. So the name itself indicates it contains phosphate atom. Just imagine glycerol, okay, 3 carbon atom, 3 OH groups. Put 1 OH group, remove 1 OH group, add a fatty acid, okay, that is at the number position. In the number 2 also add another fatty acid. In the third place, you add a phosphate. What is that? Glycerol plus 2 fatty acid plus a phosphate. We call this as phosphatidic acid. What I have done is, I have given attachment to say whatever I am talking. There are some very beautiful illustrations by some of the slide share companies. They give, so I have, for carbohydrates, I have attached one slide which describes about what all I have told for description's sake. Same way, I will also try to put the structures onto the system there so that you will be easily trying to know that what these structures are. So, glycerol with 2 fatty acid plus 1 phosphate, we call it as phosphatidic acid. What is phosphatidic acid? Glycerol with 2 fatty acids, number 1 and number 2. Then 1 phosphate group, it is called as phosphatidic acid. If you remove one of the fatty acid from this, that is glycerol, 1 fatty acid, and the phosphate, we call it as lysophosphatidic acid. Now, mostly the second position, the fatty acid attached to the phospholipid is a polyunsaturated fatty acid. The polyunsaturated fatty acid is attached to the second carbon atom. And this second carbon atom, which has a PUFA, naturally, what is the unsaturated double bond? There has to be a double bond. If the double bond, the substituent groups, if they are in the same plane, we call it as cis isomer. If it is across, we call it as trans isomer. So most the polyunsaturated fatty acids, the double bonds are supposed to be cis isomer. And it is said this phosphoric acid with this cis isomers are responsible for maintaining the fluidity of the plasma membrane. So we will talk about plasma membrane also. To this phosphate, if you attached some of the bases like choline, ethanolamine, serine, inositol. These are all the 4 phospholipids which we come across abundantly in our system. Phosphatidic acid plus choline, phosphatidyl choline. That is, to the phosphate group, the choline is attached. It is called as phosphatidyl choline. Now, to the phosphatidic acid, if you attach a ethanolamine, it is called as phosphatidyl ethanolamine. Now, if you started attaching it to serine, it becomes phosphatidyl serine. If you attach to a cyclic alcohol, inositol, we call it as phosphatidyl inositol. So now, what are the 4 different phospholipids that we come across in our system? One is phosphatidyl choline, which is called otherwise as lecithin. In some of the old textbooks, it would have been mentioned as lecithin. Phosphatidyl ethanolamine is called as cephalin. Phosphatidyl serine and phosphatidyl inositol. These are all the 4 important phospholipids that you will come across in our body. Please always remember, an alcohol in combination with a fatty acid usually has an ester linkage. So the attachment of the fatty acid here to the alcohol group of the glycerol is an ester. If this becomes an ether linkage, say at the first carbon atom, the fatty acid is attached to here, ether linkage, then it is called as phosphatidol. Phosphatidol. See the spelling. It is not tidyl. Phosphatidyl is phosphatidol, Tidal. They are otherwise called as plasmalogens. What are plasmalogens? They are phosphatidol choline, where the linkage between the fatty acid and the alcohol group of the glycerol is an ether linkage. These plasmalogens are very important physiological compounds we see in our body. Okay. So now you have seen the important phospholipids like phosphatidyl choline, ethanolamine. Then you have seen serine and inositol. Then we have seen plasmalogens, which is called as otherwise called as phosphatidyl ethanolamine. Now, if we are going to take out the alcohol and have another complex alcohol, we call it a sphingosine. Then that sphingosine being the alcohol, to which if you add a fatty acid, that is, the alcohol is instead of glycerol, you have sphingosine. Attach it with a fatty acid, we call it as ceramide. What is ceramide? Sphingosine alcohol attached to fatty acid. Now to this ceramide, if you attach a phosphoryl choline, it becomes sphingomyelin. Okay. See, for example, in one of the MCQs, they can ask the components of sphingomyelin are. What are the components of sphingomyelin? Then you can be able to write choline, phosphate, fatty acid, and sphingosine. Same way they can ask about other like phospholipids, other phospholipids also. What are the components of the phospholipid? Choline means what you will write? Choline, phosphate, 2 fatty acid, and a glycerol molecule. So the MCQs could be in any form. They can ask you like this. Okay. So now we know what is sphingomyelin. What is now to this, for example, ceramide, if it is added on to a sugar like glucose or galactose, they become cerebrosides. If it is glucose, glucocerebroside. If it is galactose, it is called as galactocerebroside. And there is also another compound we will talk, which I did talk about last day, N-acetyluronic acid, sialic acid, which is also present on the outer leaf of plasma membrane, which we call the receptors. Some of the receptors are called as sialoreceptor proteins. Okay, so these cerebrosides can also be attached to NANA, that is N-acetyluronic acid, and they can be called as gangliosides. So because they are all present in the ganglionic cells. So these are all the very important groups of lipids which you will come across in your system. What are they? One is phospholipids, conjugated phospholipids, that is the phospholipids. Then you have sphingolipids, glycolipids, glycophospholipid, the anchor that is present on the plasma, which is paroxysmal nocturnal hemoglobinuria, isn't that? So that is glycolipids also can be considered like that. Now, what are the derived phospholipids? One is the steroid. Terpenoids compound, but we'll think about the steroid nucleus. What is a steroid nucleus? Cyclopentano-phenanthrene ring system. Cyclopentano-phenanthrene. That is, 3 rings are fused together. A, B, and C. It is called as a phenanthrene ring. Then cyclo to that, you are attaching a cyclical 5-carbon atom to this. So the whole ring system is called as cyclopentano-phenanthrene ring, which is otherwise called as the basic steroid nucleus. And this will have, it can have a methyl group, you can have at 2 places. And also it can have a side chain called isocapric aldehyde. Then it can also have the OH group at the 3 position and the double bond between, say, 5 to 6. Then it becomes cholesterol. The steroid nucleus is very important because the basic nucleus, the basic ring structure present in cholesterol is this cyclopentano-phenanthrene ring system. About 27 carbon atoms are there, 2 methyl groups are there. The side chain is supposed to be the isocapric aldehyde. The 3rd position, the cholesterol has a OH group. Then it has a double bond between 5 and 6. Then it has 2 methyl groups in the ring structure. Then you have the side chain and the cyclopentano. It is attached to the isocapric aldehyde. So this is your cholesterol molecule. So cholesterol is a steroid. And you know the importance of cholesterol in our body. It is very, very important. One, we said earlier that phospholipids will play a very important role in imparting fluidity to the membrane structure, and cholesterol stabilizes the membrane structure. That is number 1. It has a very important function in the membrane, biological membranes. And you know that very well. Under the skin, we have 7-dehydrocholesterol. When a photon strikes onto your dermis, the 7-dehydrocholesterol, the UV light converts that into vitamin D. And that vitamin D is hydroxylated at the 25 position and hydroxyl group at 1 position, then it becomes the active form of vitamin D, which we'll see in fat-soluble vitamins. So it is a precursor or a starting material for the formation of vitamin D. And also cholesterol is the starting material for steroid hormones. Steroid hormones are adrenal steroids like cortisol, corticosterone, aldosterone, and also it is also a starting material for estrogen. 17-beta estradiol, estriol, the pregnancy hormone. And also it's very important for androgens like dehydroepiandrosterone, androstenediol, and testosterone. So that is the starting material for the formation of this. The problem why most of us are feeling why cholesterol is not some people think it's a very bad molecule. Why? Because the body cannot completely break it down. The 27 carbon atoms of cholesterol cannot be broken down completely. So the steroid nucleus remains as such. So that is why this has being a fat soluble component. This needs to be eliminated from the body. So what happens is that the breakdown product of this cholesterol is the bile acids. That is 3,7-dihydroxy is the deoxycholic acid, the breakdown product of cholesterol, the bile acid. The other one is cholic acid. It has 3 hydroxy group, 3, 7, and 12. Deoxycholic acid has 2 hydroxy group at the 3 and 7 position. So bile acids are very important for emulsification of fats. They are very important for digestion. They are very important for pancreatic lipase activation, and they play a very, very important role in lipid digestion. So that is why bile salts are very, very important for our system. And these bile acids are conjugated with glycine and taurine. So when I talk about taurine, you will come across, there was a question I think in the PG entrance exam. What is the essential amino acids that is present in pediatric population? One of the STEM option was taurine. Yes, that is the correct answer. They had given methionine, cysteine, and other things, and taurine was given. We will talk about this because why I am talking. Just I wanted to remember this. Taurine is one of the things that is conjugated with the bile acids. So now these are all the breakdown products of cholesterol. So we have this breakdown products of cholesterol playing a very important. So cholesterol as such is a very, very important molecule for our body. Many people think that they are not very important for us. Why? Because they are very harmful. This cholesterol is not a very harmful thing. It is a very essential biological molecule for our bodily function. Terpenes and terpenoids, they know that terpenes, polyisoprenoid compounds. Poly, that is isoprene units means CH3 double bond CH and CH2. Polyisoprene units, they are the components of vitamin A. Alpha tocol also has supposed to be vitamin E. Also, then we have the vitamin K hydroquinone. So we will not talk about those derived. This is the most important derived lipids, according to me, is the cholesterol, which we are supposed to be the steroids, which are very, very important. So, see, this is the basic concept which I have told you about simple classification of lipids, neutral lipids, conjugated lipids, and derived lipids. I told you about that.